When a new employee joins a company, it creates one account, just one. And from that single account, they can unlock their laptop, connect to the VPN, print documents, load their email, log into internal tools, and pull code from the repo. That's not magic, and it's not all SSO. SSO handles web apps. Most of this runs on something older, something that predates the web. A protocol called LDAP, the Lightweight Directory Access Protocol. The phone book every other auth system in your company quietly reads from. This is part 3, the finale. Quick recap of the series. Part 1. OAuth gives apps scoped access without your password, and OIDC adds an ID token that says who you are. Part 2. SSO lets you authenticate once and reach many systems, and SAML implements it with signed XML assertions from an identity provider. But here's the question we left open. Where does that identity provider actually look up your credentials, your groups, your attributes? Very often, LDAP. First, what is a directory? It's a specialized database, but not a relational one. A relational database is built for complex queries and frequent writes. A directory is tuned for one job: fast, read-heavy lookups of hierarchical data. Picture a corporate org chart in a database. At the root, your company. Then departments: engineering, HR, finance. Then teams. Then individual users, each with attributes: name, email, title, manager, groups. It exists to answer questions fast and constantly. Does this user exist? Is this their password? Which groups are they in? A relational database could store this, but a directory is orders of magnitude faster at it. LDAP, the Lightweight Directory Access Protocol, is how you read and write a directory. It was designed in 1993 as a lighter alternative to the older X500 standard. The implementations you'll meet: Microsoft Active Directory, the dominant enterprise directory. If you've joined a Windows domain at work, that's AD, and it speaks LDAP. Plus Open LDAP, the open source server common in Linux shops and Apache directory. LDAP really defines 3 things: a data model, how the tree is structured; a query protocol, how you search and read entries; and an authentication mechanism, the bind. Let's take each. LDAP stores data as a tree, the Directory Information Tree, or DIT. Every entry has a distinguished name. A DN, it's like a file path, but read most specific first. Take this DNCN, common name is the user. OU, organizational unit, is the department. DC, domain component, is the root domain. Each entry carries attributes defined by its object class. For a user, name, email, a user ID, a hashed password, and crucially, member of the groups they belong to. That member of attribute drives enterprise access control. When the VPN asks, "Can this user connect?" it checks their entry for the VPN user's group. Same for who's allowed to deploy to production. LDAP authentication happens through an operation called a bind. There are 2 kinds. An anonymous bind connects with no credentials, only for open lookups. A simple bind is the common one. You hand over a DN and a password. The server checks that password against the stored hash. Match, and you're authenticated. It returns a result code. In a real app, a login form, a VPN client, it goes like this. First, a service account binds and searches for the user's full DN by their username. Then it binds again, this time as the user, with their password. If that bind succeeds, they're in, and a quick group lookup handles authorization. This is LDAP bind authentication, and thousands of enterprise apps still log you in exactly this way. Now the most important idea in this whole series. LDAP is a directory protocol. SAML and OIDC are federation protocols. Different problems, different layers. Think in 3 layers. At the bottom, the directory, LDAP and Active Directory, who users are and what groups they're in. In the middle, the federation layer, SAML and OIDC, run by an identity provider like Okta or Entra ID at the top, your applications. So when you log into Slack through Okta, Slack sends a SAML request to Okta. Okta verifies you against Active Directory over LDAP, gets your groups, builds the assertion, and Slack logs you in. LDAP stays behind the curtain. The app never talks to it, the identity provider does. LDAP is the source of truth the IDP reads from. Let's assemble the whole series in one picture. You join a company. It creates your account in Active Directory, your LDAP directory, the source of truth for who you are. Your company runs Okta as the identity provider, wired to Active Directory over LDAP. Whenever Okta needs to check your credentials or groups, it queries AD. Web apps, Slack, Jira, GitHub are SAML service providers in Okta. Developer tools and APIs use OIDC, getting ID and access tokens. And the VPN skips SSO entirely, authenticating straight against Active Directory over LDAP. One identity, 3 protocol layers, one seamless experience. So the full picture, all 4 together. OAuth, delegate access with tokens, no passwords shared. OIDC, identity on top of OAuth. The ID token tells your app who the user is. SAML, enterprise SSO signed XML assertions, from an identity provider to service providers. LDAP, the directory underneath it all, the source of truth for identities, groups, and attributes. SAML and OIDC read from it. VPN clients and OS logins talk to it directly. The takeaway, these aren't competitors, they're layers. LDAP is the foundation, federation sits on top. That's the whole series. If it clicked, subscribe and share it with a junior dev drowning in Auth. Thanks for watching, see you in the next one.